And welcome to this video on Kafka and Spark streaming. In this video, it's going to be a proof of concept, a hands-on example. I'm going to walk through installing Kafka, Hadoop, Hive, and Spark, writing some code, and making a working example of Spark streaming from a Kafka source. In this video, I'm not going to go over the theoretical aspects of Hadoop or Kafka or Spark. Instead, it's just going to be a hands-on example. So you should have a basic theoretical understanding of how Kafka works, as well as maybe the Hadoop environment. Specifically for Kafka, you should know just the basics of producers and a cluster and consumers. We're going to be working with a producer, the cluster, and a stream processor, which will be Spark. In this example, we're going to collect a stream of tweets from Twitter. We'll publish the tweets to a Kafka cluster, pull the tweets from that cluster, do a transformation on the tweets, which will be doing a character count and a word count for each tweet, and save that data to a Hive table. So the steps to do this, we're going to set up a virtual machine. We're going to install Kafka, Hadoop, Hive, and Spark. We'll write a Kafka producer and a Spark transformer that will produce a stream and read the stream, and then we're going to make it work and watch it go. So throughout this tutorial, I will be referencing this GitHub README that's not complete yet, but will be soon. Just for large configuration files, I'll be copying and pasting just to make it a little easier on the video. So, as you can see here, our first step, we got to set up a virtual machine. This is possible to do on your actual computer, but I think it's easier to use a virtual machine. And if you're following along, you can make sure you're doing each thing step by step correctly. So if you haven't already, you should get VirtualBox. It's a free way to host virtual machines. After that, you should choose a Linux distribution of your choice and download a disk image. I chose Ubuntu. You can just download, oh, I'm going to cancel that. Let me pull up my downloads right here. You need an ISO image. So whatever you want to download, just make sure you get an ISO. That's the easiest way to do it, I think. So as you see, I already have mine downloaded, so I'm going to start up VirtualBox right here. And to make a new virtual machine, we'll click New. We'll name it Ubuntu. I'm going to give it 4 gigs of RAM. You could get by with a little less maybe, but I think 4 gigs is pretty good. We're going to create a virtual disk right now, a VDI, dynamically allocated. I'm going to give it 15 gigs. There we go. So we have it made, but it's kind of just the hardware right now. Nothing's going to happen if we run it. So we will click Settings, Storage, click on this little disk. This is kind of like the disk drive of a virtual machine. Click on this disk to choose a virtual optical disk file. Go to your downloads. So here's my Ubuntu desktop ISO. Open that up, click OK. And so now you see right here we have our disk image in our virtual machine. So we're good to start it up. Before we do that, let's just check a couple more settings. We do want to make sure we have internet access, and by default it's set to the NAT adapter, which does give us internet access. So you can just check that. We're going to check the internet access after we get it started. And I'm not sure where this setting is. There it is. So if you go to General and Advanced, make sure you have Shared Clipboard bidirectional. That allows us to copy and paste between our host computer and our virtual machine, which will be very helpful. So now that we have those settings on, we can start up our virtual machine. And choose your language, start Ubuntu. So I think with this release of Ubuntu, it's going to give us like a live version and then give us the option to install. It's up to you. I think it is possible to run the live version. I'm going to install Ubuntu because I'm plan on using this virtual machine for other projects. So here it is. Right here, I'm going to install Ubuntu 19. Next, next. So we're going to erase the disk, which doesn't mean erasing your disk on your computer. It's just saying this virtual disk that's 15 gigs, we're going to erase that so Ubuntu can install completely. Let's name this thing. I'm just going to choose a password I can remember. And looks like that's the go ahead button. All right, so I'm going to speed this up. All right, so the installation is complete. So we're just going to restart now. Which looks like it's that one right there. All right, so let's log in. So you may have noticed that even if you try to adjust your VirtualBox window, the actual screen of the virtual machine is small, and that's going to be really annoying if we're going to be working on this the whole time. So one of the first things we should do is go up to the top where you have your devices menu, or if you're using a PC, it should just be right here above the window, but just go to devices and go insert guest edition CD image. And so this should pop up. So we're just going to cancel that because it's easier to access it through the terminal. So open up a terminal and go into media. Then the next directory should just be your username. And then after that, it should just be the only thing there, which is VBox guest edition CD. So in this directory, you should see a file called VBox Linux Editions. So we're going to run this. We do need sudo, and then give it a /VBox Linux Editions, and let that run. All right, so it looks like it worked. We can now extend our window, and it should fit better. There we go. I'm going to make it just a little bigger. Looks like we went a little too big. Okay, awesome. All right, so throughout the remainder of this tutorial, we're going to be working just out of the home directory, so just a little tilde. I mean, you can put things where you'd like, but I think it's easier just for the sake of a proof of concept just to keep things all in the same place. Before we continue, I'm just going to simplify things a little. Since we are working in this home directory, I don't really want to be looking at like the documents folder, all these folders, so oops. So let's just remove those. There we go, we can keep our desktop and downloads. Lastly, I'm going to just increase the font on this a little. 17. I like a little margin too. There we go, that should be nice and easy to read. And this is optional as well, but I'm going to just customize the prompt a little. Okay. So that was the bash RC. We will edit that later, so I guess it's good practice. We do need to run that with source. There we go. So I just like this to be a little smaller. Just kind of tells us where we are, so still helpful, but just a little easier to read. But like I said, it's completely optional. Alrighty, so you may have noticed that when we installed the guest editions for the virtual machine that allowed us to go full screen, there was a warning that said some features might not be available until we restart the VM. One of those is the ability to copy and paste from the host machine to the VM. That's going to be very important, so before we continue, we do need to restart the VM. Okay, so we have our VM set up, and we're ready to install Kafka, which is our next step on the list. So get back to your VM, open a terminal, and the first thing we have to do is just go to the Apache Kafka download page. So if you just search Kafka download, I'm going just here to the quick start link. You can go to the download page as well. If you just click download, there's this tarball right here. You can use wget, or you can just click on it and just save file. I already have it downloaded, so it's in my downloads directory right now. So let's look at right here in my downloads, I have Kafka. So the first thing we need to do is just unpack it. So downloads Kafka, and that will just unpack it right here to our home directory. So one thing I'm going to do is just rename it so it's easier to work with. Awesome, so we have our Kafka. We can jump into and look at it. Looks like there's a folder with the binaries, which is the main thing. That and the config is what we're going to work with. If you haven't already looked at the Kafka Quick Start, I think it's a good starting place for working with Kafka. We're going to use just the basics from this Quick Start and then build off it with our Spark streaming. So as noted in the Quick Start, you do need Java to run Kafka as well as Hadoop and a lot of the other Apache environments. So let's do that real quick. We'll do sudo apt install openjdk8. So I have already installed Java, so that's what happened really quick. I did it earlier as well as downloaded a lot of the tarballs earlier because my internet's pretty slow. So this might take you a second, but just make sure you download that. Once you have it downloaded, you can check, just type Java, or you can do Java version. And that looks good. So we have Java. We should be able to run Kafka. So let's jump back into that. So before you run Kafka, you do have to start an instance of Zookeeper. So let's go bin Zookeeper server start and give Zookeeper the Zookeeper configuration settings. So now we have Zookeeper running. And one nice thing I like about this desktop environment, or at least this terminal, is you're able to name it. So I'm going to name my terminals, or at least my tabs. We have this one named Zookeeper. So in another window, go back into Kafka, and now let's start the Kafka broker. So that's Kafka server start, and we will just use the default server properties. And let that go. We'll just name this the broker. So we're just doing a one broker cluster just for simplicity, but it looks like our Zookeeper and broker communicated. So, okay, so now that our broker's running, we need to create a topic. So the topic are the things that the producers and the consumers subscribe and publish to. So we can first just check what topics, if any, exist on our cluster. So it looks like there were no topics yet, which is what we expected. We just barely started up, so we're going to create one. So we have to tell it what server to look for, and that's just the one we just barely started. 9092 is the default port defined in those server properties that we passed in. So we're going to set the replication factor to 1 because we're just using a single node Kafka cluster. And we will also just do a single partition. And now we can give our topic a name. So we are going to use some tweets as an example. So we're going to like stream in tweets and pull those out from the Spark transformer. So let's just call our topic tweets. All right, so it looks like that worked. We can check with that last command. It's going to list it. Yep, so we have our tweets topic that is ready to produce messages or publish messages to. So we can actually just test that out real quick. So again, this is all covered in the Kafka Quick Start. But if we do console producer and say the broker list is our server and set the topic to tweets, that will be able to produce tweets. And just so we can get a side-by-side, I'm going to open up another terminal. Let's shorten this. So on this side, I'm going to make the consumer. So now this consumer is listening for any changes. We'll just do that. Looks like everything's coming through. Awesome. So we know our Zookeeper and Kafka cluster are working. We can close that. We don't need it. It's a little too big. All right, so we're going to keep this broker running, and we'll keep the Zookeeper running. We're going to get out of this producer though. So that's mostly it for Kafka. One last thing we want to do is for this example, we're going to use Python as the Kafka streamer, and also we're going to use PySpark, the Python implementation of Spark, to write the transformer. So depending on your distribution, you might already have Python 3 installed. Ubuntu already has it. So if not, you will need to get that. But one thing that doesn't come installed already is the Python package manager. So you will need to do sudo apt install Python 3 pip. I already downloaded it, like I said. So once you get that, we will need to do pip3 install Kafka Python. So this is a Python library that allows us to work with Kafka. So once you install that, you can check that you have it with just by doing a pip3 list grep Kafka. And it looks like we have it there. You can double check that by just entering the Python shell and importing Kafka. And if you don't get any errors, then it looks like you're good to go. So we're not going to start using it yet. We'll use that after we get all the environments installed. But while we're installing Kafka, I thought I'd mention that. So let's check on our progress. We just installed Kafka. So next up, we're going to install Hadoop. Next step is to install Hadoop. We're just going to hop back right into our VM. And just like we did last time, we'll just open up a browser and just search Hadoop download. Probably just the top link's fine. All right, we're going to use version 2.8.5. So just click here on the binary. This should take us to a list of different mirrors we can use. And again, we could copy this and use wget, or you can just click on it and just download it through the browser. That's what I did. I already have it downloaded. So do that. Let's check out our downloads folder. Looks like we got it right here, Hadoop 2.8.5. So let's unpack it. And this will take a little longer to unpack than Kafka because it's just a little bit bigger. All right, so it looks like we have it right here in our home directory. I'm gonna rename it just so it's easier to work with. So we have Hadoop right in our home directory. So one of the first things we need to do is edit our bash RC. I'm going to use Vim. You can use Nano or one of the GUI-based editors that come with your Linux distribution. So let's just ignore that warning. All right, here we go. So I'm just at the bottom of the file. So there's a couple things we need to do, and I don't want to write them out all the way, so I'm just going to go to the GitHub README and just copy it. There we go. All right, so we do need to change a little thing. One little thing right here is, so our Hadoop home is just going to be the home directory, which is home / whatever your username is, and then Hadoop. So I did rename it to Hadoop, so that's why I did that, plus it just makes it simple. And then all these other configuration directories are usually some variation of Hadoop home, but different processes use them depending on their name. The other important thing right here is the path. So that's letting us use all the commands in the sbin and the bin inside Hadoop. One last thing is this Java home. This should be the default location that Java installed to, but depending on which version of Java you downloaded, it might be a little different. So let's just double check that. Let's open up a new window, go to user lib JVM. Looks like it's that Java 8. All right, so let's check that user lib JVM Java 8 OpenJDK. Looks like that's the one. Perfect. Okay, so we're good on that. Let's just save it, and then we need to run it just to make sure our changes take place. We can test it out by echoing the Hadoop home. Yep, awesome. Okay, so the next step is let's get into the Hadoop configuration, which inside your Hadoop folder, there's this etc. Inside that, just another Hadoop folder. So here are some of the configuration files. We're going to edit this one right here, the Hadoop env. So let's open that one up. So these two right here, there's a Java home and Hadoop configure. I'm just going to comment these out because we're going to copy and paste them in. Let's make some space. I'm going to jump back to the README. A little too far, sorry. Right here. And then again, replace the username with your name. So same thing as above, just make sure this is your Java home, and this should just be wherever your Hadoop is. Okay, so we can save that one. So while we're still in this configuration directory, we need to edit the Hdfs site XML. So I'm just going to override everything by deleting it first and then grabbing. Oh, looks like I did a load out of order. Okay, we're doing Hdfs site right now. So let's copy that one. Okay. And then the other one was the core site. Same thing, just going to override everything. Grab this. So I forgot if I've mentioned, but we're just going to use Hadoop as a single node cluster because Hadoop's designed to be run over a lot of multiple machines, but just for our example, we're just going to be using one. And so for that to happen, there will have to be, we'll mimic it with allowing this machine to SSH into itself. So let's install SSH, open SSH server and open SSH client Like I said, you might already have these depending on your distribution. But it usually installs pretty quickly. All right, so we can check service. So it looks like we do have SSH running. So we can log in or SSH into ourself by just doing SSH localhost. And doesn't look different because it's like the same thing, right? So we're gonna actually exit out of that, get back to where we started. To make things easier, we can use passwordless authentication just by running these two commands, where we just create an SSH key and then we'll save that SSH key. So let's try that last command again. So bam, we're SSH'd into the computer itself, which will allow us to mimic the like a Hadoop cluster. Okay, so now that we have that, we have Hadoop set up, and now we should be able to start the Hadoop cluster. So we're going to use Hdfs. That's a command that was found in the Hadoop bin that we added to the path, so it should be able to recognize it from here. So we're going to just say Hdfs name node format. And you'll see something like that. And then the next step is to start the distributed file system. So it's just start dfs.sh. Again, that's in the bin, so that should just run. We can just say yes on that, allow it to SSH. Okay, so we don't really know if Hadoop is running yet, so we can test that by just doing Hadoop file system ls/. So we're just going to look at the contents of the Hadoop directory or the Hadoop file system. So nothing returned, which is usually a good sign. If something was wrong, we'd see an error. But let's just make sure by making a directory, we'll just call it test. And now let's look at our contents of the Hdfs. Yep, so our test folder's there on the Hadoop file system. So Hadoop is installed and we are doing good. Sorry, okay. So let's check our progress. We've got Hadoop installed, so our next step is Hive. Let's just run through that real quick. As you might have expected, we first just got to install it. I'll show you where the install is. So I think Hive's page is a little, this is giving me issues. Okay, so you can go through here, just 2.3.5 is the one I was using. You can also go back through the Apache archive and find 2.3.5. Just download the binaries. Same thing as before, you can use wget on this or download through the browser. I already have mine downloaded, so I'm going to unpack it. Downloads, Apache Hive, there it is. All right, let's rename it. All right, we have Hive, Hadoop, and Kafka all in the same place. So let's jump into the bash RC. I'm not sure what that swap thing's about. I probably have it running somewhere. And let's export the Hive home. That is going to be where we just saved it, which is home username Hive. And then let's add that to the path. So I'm just going to follow the syntax from up above, where we just say path and then just add on Hive home, and then we want the bin directory because that's where all the commands are. Okay. All right, so we need to run it. So now those changes took place. So now we should be able to Hive to do. Now we should be able to do Hive version. All right, so we got Hive 2.3.5, which is what we downloaded, so that's looking good. So to use Hive, we need Hive runs on top of the Hadoop file system. So we need to make some directories the Hive can use. So let's do some more Hadoop file system commands. So Hadoop fs, make dir, you can use the p flag, user Hive warehouse. So that p flag will make all of those directories for us. Let's also make a temp directory. We don't really need the p flag on that one because it's just one directory. Then let's change the permissions on those. User Hive warehouse. And then let's do the same for the temp directory. All right, so those are necessary for Hadoop to write to. All right, let's jump into Hive and go into the conf folder and change some of these configurations. So first, it's not here. Oh, it's right here. It's just like a template that might explain some of the variables. We're just going to make a new one called hiveenv.sh. And I'm going to copy from the GitHub. We'll grab these. Oops, we got to change these names. All right, and then next up, we need to make a Hive site.xml, and I don't think it exists. We're going to make it from scratch. .xml, and we're going to copy this. This one's really big, so happy we're not have to type this in. All right, so one thing to notice here is that's the directory we just made in Hdfs. That's the default location for the database. Then we have this metastore URIs. That's going to allow us to connect to Hive from our Spark file that we're going to write later. All right, so we have our Hive site. And we should be good to go. One thing, I'll just point it out real quick. Once we enter Hive, we get this annoying warning about this SLF4J file. It gets kind of annoying. There's just multiple files, so one way you can deal with that, if you just go into Hive, and then if you just move the lib, I think it starts with a log SL4J, and just rename that. So it'll still work fine. There's just two of these files from our other, from either Kafka or Hadoop that's making issues. So just rename that. You can get rid of that warning. It's not a big deal though, if you don't. All right, and then let's create the database that we're going to be using. So remember, we want to stream, once we grab tweets from Kafka, we're going to save that data to the database. So that database will be in Hive, so we're going to use the schema tool, do init schema, and then db type is Derby. So that's just, oh, not a dash. Just like that. Okay, and then the last thing we're going to do, sorry, not that. We're going to do Hive service and metastore. So we need to start that metastore server. So there it says we've started it. It's not going to give us too many logs or anything, but that's fine. Let's name that. We will need to keep that running. So let's open up a new tab. So now we have that metastore running. We can enter Hive. Okay, so now we're here in Hive. Let's just do a little query. Show databases. Should just say default. Yep. Show tables, nothing. Let's just make sure we're using the default. Okay, so let's create a database. We're going to do create table. We're going to call it tweets. And remember, we're going to keep the text of the tweet. We're going to count how many words there are. And then we're going to count the length of the total tweet. So that's the schema. We're going to give a row format. Delimited fields. So this is kind of a tricky part when we have to decide what is terminated by. A lot of times you can just do space if you know the kind of data you're getting. But we do know that tweets have a lot of spaces, so that's not going to work. Thinking you could use a tab, but there's a good chance that tweets enter tabs. I'm not too familiar with the restrictions on tweets, so what I decided to do, which might not be the best way, is just kind of choose a random sequence of characters. So I'm just going to do like a / pipe. There is a chance that people might have that sequence of characters in their tweet, but I think that'll work fine. So, and then we just have to say stored as text file. All right, so if we do a show tables, there's our tweets table. And we're not going to do count, so I'll just do a select star. There's not going to be anything in there because we just made it. But as we go along, there will be something in there, and that'll be the fun part. Okay, we can just, we'll get out of the shell so we don't get too clogged up. So let's check in. We have installed Hive. Our next step is to install Spark. So let's just keep on going. Let's see. First step, as always, download Apache Spark. So choose one of these. We got a Hadoop 2.8, I think, so we do want the one later. These ones, they are both stable, so I'm just going to go for the later one and just download that. So download through the browser, through the console. I already have mine downloaded, so you should get a download like this Spark Min. So first step, to unpack it. Okay, well, let's rename it. So similar to how we needed Java before we started using Kafka, we will need Scala before we start using Spark. So Spark was written in Scala, and it does require it on the system to run. So let's check if we have it. We don't. So let's install that real quick. All right, so let's check it. Scala version. Awesome. I think it also comes with the Scala compiler, although we're not going to need that since we are going to be writing our code in Python. So that said, you should already have pip3 from when we installed Kafka Python, but we will need PySpark, the Python implementation of Spark. So do a pip3 install PySpark. I already have it, so you can, if you want to check, you can do a pip3 list. Yep, so we have our PySpark, and we have Spark, and we have Scala. So one thing we need to remember is to add, if we go into the Spark, we have the bin folder that has all those commands like PySpark and Spark submit are probably the other one we're going to be using. So let's make sure we add that to our bash RC. So that's home, username, Spark bin. Run it and give it a test. So we can just start with PySpark. So this is one issue. It says it can't find Python. Depending on your distribution, you might not have Python 2. So what we should have done back when we were in our bash RC was to make another edit where we export PySpark Python, and we just set that equal to Python 3. Okay, oops, ls. All right, let's give that another try. Oops. That's what happens when you don't run your bash RC after. All right, so it says it tried using Python 2 first and couldn't, and then used that environment variable we set, so now it's using Python 3. So here we go, using Python version 3. We have Spark right now. This shell allows us, it already creates a Spark context for us and the Spark session, which is something we will get into very shortly. One last thing that we will run into if we continue, but we might as well take care of right now, is that there is a certain jar file that isn't, that we need to download separately. So, I mean, you'll get this error if you just continue without this, and it'll tell you where to go, but I think it's searchmaven.org. There we go. We want a Spark streaming, and then it's 0.8. And so we're going to want to grab one from Apache. And 0.8, 2.11, that's the Scala version. Can't tell the difference between those two. Oh, goodness. Yeah, so we want this assembly one. And 2.43. Okay, perfect. So we'll just have this downloading. Like I said, we'd hit an error where it says this library isn't included, and then we'd have to, it'll tell us the link to go get it, but might as well just get it right now. All right, so that is, for the most part, install Spark. Unless we forgot something, we might hit an error later that we can go fix, but I think we got it. So now our environment is set up, and we can go on and start to write our producer and our Spark transformer. All right, so we're at our final step where we need to write the Kafka producer and the Spark transformer. One thing I forgot to mention is we're collecting a stream of tweets from Twitter. To use the Twitter API, you will need a Twitter developer account, which is easy to get, it just takes a while. So you might not be able to follow along completely, but I did come up with an alternative so we can still use Kafka and Spark Streaming if you don't have the Twitter API. So let's jump back to our VM and get started. So remember, we have our Zookeeper running, our Kafka broker running, and our Hive metastore. So I was thinking that we could just write the code together, but that's a little boring. So I already copied the code in from the GitHub into this files. There's the files you need, for example. So we do have a tweet stream, and for people without a Twitter API, I made up a little like fake tweet stream, and then we have the transformer. So let's just take a look first at the tweet stream. Let's go to the top. So we use that Kafka Python package we installed at the start. The secret config is just where my API keys are. One thing I didn't show is you really need to use pip to install the package tweepy. So it's going to look at some topics on Twitter. We're just going to look at all tweets that have to do with pizza. We have our Kafka broker, our Kafka topic that we made earlier called tweets. And you can just look at the Twitter API docs on this. They give a really good example of extending their streamer. And so we just say each time we get a tweet that matched what we were listening to, I just cleaned up the tweet, getting rid of the retweet and any links. Then we just connect to the producer, the Kafka producer. We send to that topic the tweet, and then we just encode it. And then this is just for logging any output so we know that it's working. So this is where we set up the API, all the authentication. We create our streamer, and we just tell this stream to listen. And down here is where we actually made the Kafka producer. You just say producer is equal to Kafka producer, and then give it the list of the Kafka brokers to listen to. All right, so that's pretty simple. As for the fake tweet stream, depending on your Linux distribution, you might have a word list in the user share folder. So I just grabbed that and then connected to the Kafka producer like before with the Bootstrap servers. And then I just add in some random words and print them out. So for example, well, first let's change the permissions on those so we can run them easier on the tweet stream. So the fake tweet stream just kind of says a bunch of garbage and does it kind of a random random intervals. And with the tweet stream, I don't think I have it printing out the messages sending tweets, but those are actual tweets coming in. We will be able to see that on the other side. All right, so that's it for the producer. That's going to produce to the Kafka stream. That's going to produce to the Kafka cluster. And the transformer is going to take from it and put into Hive. So let's look at that next. So this one, we need to import Spark, Spark context, Spark session, Spark streaming context, and the Kafka utils. This Kafka utils is why we had to download that jar folder, which let's check that we have that still. Yeah, this jar right here. So before we forget, let's move that over. Spark streaming, let's move that into our home directory. Okay, so let's get back to here. So starting down right here, we create a Spark context, use that Spark context to create a streaming context. This number is like the interval between the times when it runs this batch, so it's not exactly real time. For example, if we set this to 60, every minute it would gather all the new data that came in the stream and then run the process on it. We're going to do it 5, which is pretty low, but it allows us to see it, so it's a little more interesting for us. We create a Spark session, which we use these config to say this should look familiar, where that database is. That's that Metastore URI, our Metastore server that's running. Right here is where we connect to Kafka. Sorry, good thing we're looking through this. This is our topic. We want to be looking at tweets, not messages. But that broker list is our Kafka broker at 9092. Here's where we transform our lines. So for each tweet, we grab just the text itself. We get a count of the words, and then a count of the total length. And then right here is where the real processing is happening. So this transform variable is a direct stream object, and it's just built of a bunch of RDDs, which is another object that's similar to a data frame. And we just say for each of those, go handle it, which is this method up here. So it passes in the RDD, and if it's not empty, we connect to that Spark context, or the Spark session, and we create a data frame from it. So we take that RDD, create a data frame, give it the schema of text, count of words, length. We're going to show it to the console so we can monitor it a little. And then we'll say data frame, write, save this as a table to default tweets, which is what we have in Hive, formatted as Hive, and we're going to append to the table. We don't want to erase it each time. And then at the bottom, we use our SEC, which is our streaming context. And we start, and await termination just says keep going till we tell it to stop. So I know we kind of went through that quickly, but let's see it in action. So double check. Zookeeper's running, our broker's running, our Metastore's running. In this shell over here, I'm going to get into Hive. Let's rename this Hive. And this one will be our producer. And this one will be our transformer. Use default. Show tables. Let's just get our command ready so we can use it again. From tweets. Okay, so nothing there yet. So let's start producing by running tweet stream. So it's sending tweets to the Kafka queue. Let's start our transformer. We're going to use Spark submit. We need to add in that extra jar file, jars, and our actual file. Okay, one sec. Let's stop that. It looks like unexpected character. Maybe I had an issue pasting everything in. Oh darn, okay. Yeah, I don't think it's good to paste things with Vim. Let me just clean this up real quick. And just let it overflow. Sorry, I'm not an expert of Vim, so this is a little slow. Okay, that's not as clean looking, but it should fix it. All right, so we got that running. It's gonna be looking for stuff that's not there because we paused our producer, but I guess we should have checked that one first. All right, let's start this up again. Our tweet stream. So it's sending tweets over. And it's going to wait at 5-second interval before it gathers them all. All right, so this is someone talking about pizza probably. We got the text, the number of words, and the total length. And you can kind of ignore these errors. All right, so here's some other ones. We can't really read them very well because it tries to form them nicely for us. But they're coming through, it's processing them, doing a Spark transformation on it. But now let's check if we are getting them on Hive. It looks like we are. Obviously very bad format, but what can you expect? Let's just do a count on it. Okay, that's going to take, it's going to do a little MapReduce job, so it might take a bit, but looks like we already have 144 tweets in, and they keep on coming, and this is just keep on processing. Looks like this person talking about pizza, 5 words of 27 characters in length. Let's run that again. Wow, now we have 216. So I'm going to stop this guy. Oh, look, he even gets a little emojis too, that's fun. So I'm going to quit this guy too. Let's see how much we got total. So 244. So hopefully that gives you a good example of, I mean, obviously this is pretty simple. We were just counting the characters and the words for a tweet, which isn't very interesting. But it does show you that you can have a Kafka cluster, make a producer that creates a stream, and as that stream is continually producing, you can have some app that deals with it. And this stream processor can do anything. It's really, ours was pretty simple. We were just counting and saving, but you could do a big transformation on it and save it to your Hive table. And then that Hive table can be used for many other purposes. So hopefully this does give you a better working example with this, and I'm sure I missed something or explained something wrong, so please forgive me for that. But thanks for watching.